Adding polynomials is one of the least complex things that we're going to do, and it certainly borrows from information that we already have, or knowledge that we already have, our skill set that we came into this class with, really. All we're doing really now is really talking about it differently. So I just want to review the idea of like terms, because this is one of the big things that this is building on. So the idea of like terms, of course, we can combine like terms. We identify like terms as terms with the same variable or variables, and those variables have the same exponent. So these are the two key points when we're trying to identify like terms. Once we've identified like terms and we can combine them, we add the coefficients. Remember, this is just a shortcut, so we don't have to do it the long way. So we add the coefficients and keep the exponent. So this is how we combine like terms, and this is really the foundation for everything we do. When we're adding and even subtracting polynomials, we just have to add one extra thing for subtracting. So we look at this example that we've got, and the first thing that we want to do is, the first thing that I would do when I look at this is I would say, I'm going to rewrite this. Now, the thing that we note when we have the parentheses around these two polynomials, here we've got this parenthesis around 4 terms and this parentheses around 4 terms. Now, and the idea here is that this is basically saying I'm adding a 4-term polynomial to another 4-term polynomial. So what we're going to do now is, because this is a plus, and there's no number before anything, there's no exponent on any of these parentheses, we can literally just drop the exponent, or excuse me, not the exponents, don't do that. We can literally drop the parentheses. So I'm going to do that, and as I do it, I'm going to put the like terms together at the same time. So I'm going to take 4x to the 4th power. I'll mark that off. I look for any more 4th powers, and I don't have any 4th powers over here. So I see I have a 3rd power though, so that's going to go next. So plus x cubed. And now I'm going to look for, you see what I'm doing? I'm putting it in correct order, starting with the highest first. So now I've got 2x squared. And here I've got another 2x squared, so I'll add that one. So now I'm putting my like terms together, and I'm putting it in descending order, so I'm putting it in proper form at the same time. You'll also notice that up here that I'm checking things off as I go, so I know that I've gotten everything and I don't try to use something twice. So here's a plus x, and you may even want to put that 1 in there if you're one of the folks that likes that. And then a 5x. So again, I've got some like terms together. And then here at the end we have a constant of plus 7, and here a constant of plus 1. So we have plus 7, plus 1, and again, those are like terms, I can combine those. So the first term here doesn't have a like term, so I'm just bringing it down, 4x to the 4th. The next term, again, no like terms, no other terms that are cubes. Now I can combine these like terms by adding the coefficients, so that's 4, and then keep the variable. The variable is x squared. And now I do the same here. I've got these x's, and again I just add the coefficients. So I've got a plus 1, I've got a plus 5, so plus 1 and plus 5 is plus 6. Keep the variable, and then just add those constants, plus 8. And then of course I'm going to do a recheck just to make sure that I don't have any like terms, but theoretically if I did my job well on this line, it's literally just to check to make sure I didn't miss anything. And here you can look at this and you can see everything's in correct order, 4, 3, 2, 1, and no variable. So we did a good job at everything's done on this thing. So let's try the next one here. So again, we do the same thing. We look, we see that we've got two trinomials that we are adding, and when we are adding, we know that all we're really doing is combining like terms. So I'm going to drop the parentheses as I go and combine the like terms at the same time. So I've got 2y cubed, marking them, plus 4y cubed. Then I've got negative 5y squared, positive 2y squared. Now I've got an 8y, and a constant here. I'm going to go ahead and put at the end. So you'll notice that I gathered my like terms and put everything in proper order all at the same time. It's a nice time-saving thing to do while keeping you really organized. And I'm just underlining the things that are the same. So now I look at this and I see that I've got my y cubes. So when I'm combining like terms, I just add the coefficients, keep the variable. I again add the coefficients. I've got negative 5, positive 2. Keep the variable. These guys are not like terms. Nothing I can do with them. I just bring them down, do a double check to make sure I don't have any like terms that I missed, and it looks like I'm good to go. Now let's do this next one. The next one is again two trinomials. Again, I'm going to kind of suggest that you pause this for a minute so you try this on your own before watching me do it. So, you know, I'm just kind of babbling right now to give you time to pause. So assuming that you did that, now I'm going to go ahead and look at this. And we've got two trinomials. Again, we are adding. And the parentheses are, you know, again, the parentheses are just there to say, hey, this is a trinomial. They're not performing a mathematical function. So now I'm just going to start getting rid of the parentheses, rewriting it, and putting everything in proper form while gathering like terms. So I've got 6x to the 5th. That's our highest exponent. Now I don't have any more x to the 5th, but here's an x to the 4th, so that goes next. No more x to the 4th, but here's an x to the 3rd, so that goes next. No other x to the 3rds here, but here's an x squared, so again that goes next. And you'll notice that I'm keeping the sign that is in front of it. Then I have a 4x. And then last but not least, I have that little constant hanging off the end, and so it will. And you'll notice that when we rewrote this, we didn't have anything that was the same. So while we were looking together like terms and just rewriting it in proper form, we're actually done now because we don't have any like terms. We already figured that out. There was nothing that had the same variable, exponent on the variable. So this is our done answer. The next one is a trinomial plus a binomial. So again, I look at the same things. I see that I'm adding. I know that the parentheses aren't performing a mathematical function, so I'm just going to start getting rid of them. Here's my 3x squared. And I'm looking for other x squareds. Here's another one. So I'm going to add 6x squared. Now I've got a 3xy. I don't see any other xy's, so I move on to 3y squared. And here's another y squared, 2 plus 2y squared. And now I'm going to combine like terms. So I see what I've got here. These are like terms. These are like terms. So when I have like terms, I know that all I have to do is add the coefficients. Add the coefficients and keep the variable. 3xy, no other terms that look like that. But here I've got some y squared, so I just, again, add the coefficients, keep the variable, and I can see that there's nothing else that I need to do here. So this is a done deal.